Welcome again, everyone, and thank you for joining us on today's webinar, Specialty Chemical Improving Operational Efficiency. I'm Allison Sterling, Marketing Manager at Emerson Micromotion, and I'm pleased to welcome you to our Emerson Flow Expert webinar series. Before we begin today, I'm going to give you a quick moment to acquaint you with that webinar environment. On your screen, you should see a presentation window on the left side, a Q&A chat window in your upper right-hand corner, media player controls, and a resource box with related content that you can view and download during the event. You can resize, move, or minimize any of these windows during the event to fit your viewing preferences. At the bottom of your display, you should have a row of icons that gives you added capabilities. You can share this webinar via social channels or request a visit from one of our Flow experts. Throughout our presentation today, we do encourage you to interact with our speaker by typing in questions and comments using the chat panel, and we'll answer questions at the end of the webinar. We are also recording today's webinar, and we will make the recording to the webinar available to you tomorrow via email, along with sharing you the links of those related resources. And on today's webinar, we are lucky enough to have joining us Robin Charret. Robin is the Global Chemical Industry Solutions Manager for the Flow businesses of Emerson. That includes Micromotion, Rosemont Flow, Roxar, and Daniel Products and Systems. Robin started with Emerson in 2008 as a Rosemont account manager in Baton Rouge, Louisiana. She has since held a number of chemical-specific roles with various Emerson Flow businesses. Prior to joining Emerson, Robin sold specialty chemicals throughout the North America Gulf State region, and she is a chemical engineer with an MBA, and in her free time, Robin volunteers as a naturalist educator at the Audubon Nature Institute's Insectarium in New Orleans. Welcome, Robin.
Thank you, Allison, and good day to everyone. Thanks for joining. Today we will discuss how improving flexibility in your process can not only help you get more out of your assets to better serve customers, but how it can also directly improve your bottom line through the elimination of waste and rework. We will also touch on layering instrumentation solutions to improve the visibility of potential hazards and allow your people assets to better manage those conditions. Before we jump in, I'd like to take a moment and define the particular segment that we will be addressing today. As defined by the Society of Chemical Manufacturers and Affiliates, specialty chemicals are manufactured on the basis of their performance or function. They can be single chemical entities or formulations whose composition influences the performance and processing of the end product. Specialty chemicals are closer to the customer of the final product, closer to the consumer of the final product. Raw materials are often more expensive than, say, petrochemical raw materials, and the sources of those raw materials can be much more limited. While specialty chemicals can be produced by batch or continuous operations, for this discussion, we will be focused primarily on batch processes. However, many of the automation attributes we will highlight can be applied to continuous processing with similar benefit and result. When we work with your industry peers, there are some high-level challenges that we hear specialty chemical companies are dealing with. First and foremost, your industry is completely different from commodity chemicals. While commodity chemicals differentiate solely on cost, you can also differentiate on quality. You are much closer to your customer base, and the customer demands are much more varied. This poses challenges to your production palette and consequently production flexibility, further impacting your supply chain with more just-in-time delivery expectations. Of course, all of this has to happen without unplanned downtime, which can also disrupt supply chain and impact your product quality. Secondly, the world is seemingly getting smaller. Competition is never far away in a global market and can make your margin for error slimmer than it used to be, particularly since customer loyalty isn't what it used to be. Thirdly, maintaining skilled headcount in your plant is becoming more and more of a challenge. How can you replace some of your retiring, experienced operators quickly? And how can you be sure that in an ever-changing, highly complex environment, that your operators and technicians are fully trained and know how to get actionable information out of your plant? This brings me to the last point, regulatory compliance, or sometimes referred to HSSE, or Health, Safety, Security, and Environmental Compliance. Apart from the human factor having a huge impact on your HSSE performance, we see the ever-growing regulatory pressures across the globe as one of the main future challenges. So let's take a moment here to get some interaction with all of you on the phone. We just talked through a few of the common challenges that we have been hearing about. Now we would like to find out from this audience which ones are the most troublesome for you. So please take a minute to consider and vote on the most impactful business challenges for you and your company. Is it meeting customer demands, asset utilization, retaining skilled employees, staying compliant both in safety and environmental, or is it the ever-changing global markets? We'll give it a couple more minutes, a couple more seconds. Okay. So taking a look at the results, it looks like we have a tie between meeting customer demands and retaining skilled employees. So both of those we will try to touch on as we move through this presentation. And hopefully some of the other opportunities will also be addressed that can help those with asset utilization and staying compliant. So throughout the industry, cost pressures can lead organizations like yours to spend less on maintenance and replacing older equipment, while encouraging plants to source raw materials from a variety of suppliers around the globe. While these factors reduce costs, they can complicate production and more unplanned shutdowns and batch variability. To improve customer service, more plants are shifting from reactive production to proactive. They're intervening in batch operations earlier in order to ensure final product quality. While this element has the potential to improve the reliability of each batch, it only works if plants can find useful data in the informational noise. Today we will talk about these three pillars: reducing customer lead times by better managing your batch cycle time, capturing higher margins by eliminating off-spec batches, and improving safety by predicting and proactively managing events that could lead to unsafe conditions. Let's now take a look at the first point of discussion, reducing lead times and improving utilization. Manual data logging, operator rounds, and checking devices that are perfectly fine are all activities that could be wasting many precious hours in the process. Our customer sources suggest that up to 62% of the work performed by staff is non-value add, and all of this leads to average plant utilization or overall equipment effectiveness of 75 to 90%. Unfortunately, many of the problems that play havoc with batch cycle times can seem to respond on the whims of chance. Equipment breakdowns or other availability problems can crop up unannounced, as can ordinary human errors. Finally, some batches seem to veer off spec more often, so that time-consuming end-of-batch adjustments, well, they just start to become a standard part of the process. The three main issues we hear from our customers are that they want to, 1, improve equipment availability, 2, be less reliant on manual operations, and 3, perform fewer end-of-batch adjustments. To improve availability, you'll need to be able to get a clearer picture of batch delays. You'll want to prevent and solve valve and equipment problems with minimal downtime, and you'll want to reduce manual errors by using automation to keep a range of manual interventions on track. And for keeping your batch from going off spec, you'll want to use solutions to make in-situ interventions that keep the batch progressing properly and without introducing new problems. Some of the technologies we use are enhanced diagnostics on instrument and valves, batch management solutions that streamline process whether you have a simple or complicated batch, precise measurement and control so you can consistently and accurately dose or charge your batches, and powerful batch analytical tools that let you predict the outcome and give the operator insight in real time on how to bring the batch back on track. Also, with the current technology, all of this is at the fingertips of the operator in the field. So delays and misunderstandings due to the classical field to control room communications are a thing of the past. So let's take a look at some of the automation solutions that may be of interest. While Emerson has solutions for all 4 of the items in the right-hand box, today we'll be looking at automation technologies that can help with precise batch charging and in-situ measurements that can help keep a batch on spec during processing, or at least allow for corrections in real time, saving lab work and potential rework time. First is the brand new 5700 micromotion Coriolis transmitter, the next generation of a long line of cutting-edge micromotion products. You'll feel confident with the measurement with some of the new features. With 5 output channels, you can select and order the exact combinations to fit your needs. It allows combinations that were previously unavailable, like being able to get flow, density, and temperature out of your sensor. Smart meter verification. While this is not a new option, I'm sure many of you are using it, it is one of the most requested options for critical measurements where the users want to constantly validate the sensor health. Zero verification. To take the guesswork out of commissioning or reconfigurations, gone are the days of having to zero your new meter on the process before operation. In fact, the factory zero will, in most cases, be the most accurate zero the meter will have. Zero verification actually checks the block-in and process stability, and the algorithm determines, if needed, if the meter should be zeroed or not. The 5700 also offers faster, cleaner transmission of data. When milliseconds count in your fast control applications, signal speed and resolution are key. The 5700, that's the new high bar for providing the fastest response time and over 3 decades of knowledge in Coriolis signal processing to react quicker than ever in dynamic processes like batching and fluctuating conditions such as in train gas. You can also learn from your processes using the embedded historian that captures and stores 1-second data up to 30 days and 5-minute data, the min, max, average, and standard deviation, for up to 15 years. This data is in a non-proprietary format and can be analyzed through many common programs. And while micromotion is the best in train gas handling capability on the market, we've also included real-time indications of such multi-phase events. A new software feature, two-phase flow indication, is aimed at bringing more concise information to users about the condition of their fluid. Whether you have a single phase, moderate entrainment that may impact your accuracy, or severe entrainment that will impact both accuracy and repeatability, you can get the notification via display, digital registers, or mapped to an analog output. Here's a topic that we don't talk about very much. So let's take a look at fork meters. A lot of our customers use the Coriolis technology as a densitometer, but when you need additional measurement confidence, we have a density fork offering. The vibrating fork is inserted into the liquid to be measured, and its tines are vibrated piezoelectrically at their natural frequency, with the natural frequency of the system changing with the density of the liquid in contact with the tines, similar to the behavior of a tuning fork for those musicians in the audience. Some of the benefits you could realize from our density fork is reliable measurement even in aggressive acid, alkali, and slurry applications with multiple wetted material options. Increased reliability of product interface detection with a highly accurate process measurement. Improved operator safety by reducing hazardous liquid exposure risks through use of an inline device where no manual sampling is required. And you can get enhanced readings like dynamic, kinematic, and referred viscosities and densities from a single device by using the external inputs of temperature, pressures, or flow measurements. A good application may be in multi-stage reactors or columns, where oftentimes feed composition represents a significant upset to production. For systems where composition can be determined using density, a density meters to monitor the feed in various stages throughout the column can help better control the efficiency of the equipment. Additionally, the internal RTD allows you to take temperatures at each stage for reaction profiling. Using wireless HART technologies to pull off those extra variables can be an affordable way to add automation to your process. Similarly, the micromotion fork viscosity meters can offer in situ process insights. The viscosity forks function like the density forks, but they also take into account the bandwidth of the time's natural frequency. The larger the bandwidth, the higher the viscosity. The smaller the bandwidth, the lower the viscosity. If your reaction rates can be determined using viscosities, this might be a great way for you to be able to eliminate lab samples. The rapid response to changes in viscosity allows operators to detect and react to fluid changes as they happen, rather than having to rely on an average sampling, a potential real-time batch savings. And if cleaning the system is a requirement, we offer retractable options to make the job easier and less time-consuming. We've now covered some ways to improve your asset utilization, but what about improving your batch accuracy? If your final product doesn't meet customer specifications, you might sell it for less, rework it, or scrap it and start all over. All of these options limit long-term asset performance, but many root causes are hard to detect, prevent, or correct. When you produce a bad batch, you've already lost time, resources, and money, and each additional out-of-spec batch subtracts even more. So ideally, every final product would be on spec, but it's difficult to make the right corrections during the process to save quality and can seem impossible to prevent problems introduced by instrumentation and human errors. Similarly, it's hard to detect variations in raw material quality and to correct for them to ensure final product quality. As a result, bad batches can seem to arise without warning, damaging your bottom line and potentially your relationship with your customers. The three main issues we hear from our customers are that they, 1, have trouble keeping batches on track throughout the process, 2, manual intervention and untrustworthy instrumentation reduce their batch repeatability, and 3, that they cannot correct for inconsistencies in raw materials. With statistical insight and new measurement capabilities, you'll get to detect and correct a batch before it goes off course. You'll also be able to prevent instrumentation and manual errors that can ruin a batch unexpectedly. Finally, you'll gain the capability to detect and correct for variations in raw material concentration. And you'll put your plant on a path to consistent on-spec production. With the newly gained insight in your batch and the ability to act timely, you can improve your first-time metric with as much as 21%. So our customers tell us their right first-time metric is 40 to 70%. So we'd like to see if you think your facility is on par with this statistic. So do you get your batches right the first time less than 25%, 25 to 50%, 50 to 75%, 75 to 90%, or can you get your batches right the first time greater than 90%? We'll take a few seconds here and allow people to chime in. Okay, let's take a look at the final result. It looks like we have the majority here is 75 to 90%, so that's good. But we still have quite a number of people that have the opportunity for room for improvement. So while Emerson has many solutions that can be employed to help improve your batch operations, we're really going to focus on the charging and dosing instrumentation. Oftentimes, the most critical start to a batch is a highly accurate charging of materials to the reactor. Volumetric measurements are commonly used, but the volume quantity of the material can be impacted by changes in the atmospheric temperature and/or pressure. So we would like you to consider the flexibility of a mass flow meter. And with good sizing, you can select a Coriolis meter that would accurately measure the mass of a variety of materials being charged. Reducing the need for multiple feed lines and reducing the need for pressure and temperature readings used for compensation and providing the most accurate measurement technology. What else can impact your charging or dosing accuracy? How about bubbles or entrained gas? When a pipe goes from empty to full to empty again, the transition period between those conditions will oftentimes be a large source of inaccuracy on the charge. But if a meter is better equipped to handle those transition periods when there is some entrained gas in a liquid, you will inherently have a better charge. The Elite and F-Series meters can operate with an uncertainty contribution of less than 1% with shorter batch times. And the micromotion meters are proven to handle entrained gas better than any Coriolis meter on the market because of the tube vibration frequency allows for better performance under those conditions. Additionally, if an acid or slurry mixture is being charged, concentration can be measured along with the flow to ensure proper quantities are used in the reaction, staying on spec from the start and not having to wait for lab results. So let's take a look at a real customer example. This story takes place in Turkey at a Unilever facility that uses silicone feedstock to produce shampoo. An automatic silicone mixer line was a major investment by Unilever to meet increased demand of some of their shampoo products. The accuracy of the blending process on the mixer line was critically important to the quality of the final product. But after the new mixing line was started, Unilever discovered that the original Coriolis meters, not micromotions, were unable to measure feedstock flow because of the entrained gas in the silicone. Additionally, the process was operated under a vacuum to help separate the bubbles from the silicone and improve the quality of mixing. Emerson's Micromotion Elite Coriolis flow meters feature low-frequency flow sensors that improve flow accuracy in the presence of two-phase flow. And a new digital transmitter also considerably improved the accuracy and stability of the signals from the flow sensor. Enhanced signal processing as well as the sensor stability and design ensured the accurate measurements. The system design engineer, Attila Bozkaya, stated that the test concluded that Micromotion Elite Coriolis meters are the only meters that could successfully measure the feedstock flow with high-density bubbles. Unilever was also able to reduce their operation costs by 17% by eliminating a waste scale process that they had tried when original meters were unable to function properly with the entrained gas. So based on the performance of these meters, Unilever actually installed an additional 12 Micromotion Elite NF meters at the Turkish facility when the capacity of the line was increased with 2 more of the mixers. Furthermore, Unilever has recently installed some Elite meters in Nigeria to help measure detergent slurries. So the bottom line results of this were the assured quality of final product and enhanced health and safety. They were able to reduce their operating costs, as mentioned, by 17%. It saved them 10 to 15% in production time. It reduced their raw material waste by 1 to 2%. Reduce their energy usage, and it minimized risk of spills and environmental issues. Now for the third pillar, it's safety. And safety is an area Emerson has been focused on across all of their businesses. So HSSE is a broad subject, and Emerson has many solutions ranging from systems for detecting flammable or toxic gases, monitoring pressure relief valves, detecting flames, emergency shutdown systems, burner management, fire and gas systems, flare monitoring, safety shower monitoring, people mustering, and much more. But this presentation, taking into the complexity that comes with batch production, I wanted to focus on the human factor. And health and safety and environmental incidents are the last thing you want to happen at your plant. You do everything you can to understand the hazards and design them out or manage them appropriately. However, even with the best safety plan in place, there's always residual risk to manage. Clues about a developing incident can go unnoticed or overlooked. And when abnormal situations are happening, personnel don't always know the right details or who does what. Plant operators and technicians are busy thinking about batch scheduling and maintenance issues, shift notes, lockout, tagout, multiple DCS or systems for maintenance, important alarms, not to mention the nuisance alarms, production numbers, and the list goes on. And to further complicate the matters, we already discussed the issues of our changing workforce and losing the more experienced people to newly trained and less experienced ones. So we suggest a layering approach, layering simple solutions to reduce the complexity, thus making your facility safer. In layer 1, we would use instruments that are engineered with safety already front of mind. Layer 2, we would utilize predictive diagnostics where it's most critical. In layer 3, invest in alarm management tools. A quick industry note. Recently, the Chemical Manufacturers Association released a report that attributed 26% of incidents to operator error. That number is conservative by some accounts and no doubt highlights the significant role operators serve in a plant incident-free operation. Not only being able to understand the alarms operators might receive, but to also be able to take appropriate action in a safe manner. So let's look at some of the layers to help. Our first layer starts out in the field with instrument design. And these are just two examples of better instrument designs ensuring worker safety and process containment. The first is the Rosemount 8800 vortex meter, which was designed with no ports and no crevices, but rather a cast or all-welded body system design, isolating the vortex sensor from the process and allowing maintenance to the sensor without shutting down the process. While the design itself is the safest available, for extra security, we offer an option to include a needle valve in the neck of the meter to check for any potential breach before servicing the sensor or transmitter electronics. It also is a gasket-free meter body, further reducing potential of leak points. And a dual and quad vortex design is available for redundancy, further eliminating line breaks or additional piping links. The picture shows our quad vortex with 2 out of 3 voting for the safety system, which are the three yellow capped transmitters, and one of the transmitters for the control system signals. So we've talked mostly about flow meters today, but safety is extremely important throughout Emerson. So we also wanted to show an example from Rosemount. So consider the 5300 guided wave radar. This radar is for the extreme applications where temperature and pressure rise to dangerous levels. You can feel safe using the high temperature, high pressure probe, which is provided with 2 seals, one primary made with ceramic insulators and graphite gaskets, and a second that's hermetically gas-tight sealed, allowing for safe operations at any time without any risk of leakage. The seal is also long-term stable thanks to the flexible probe load and lock system with active springs, which compensates for long-term wear and tear. To further prove the safety of this part, all high-temperature, high-pressure seals are tested to 1.5 times its maximum pressure rating before it leaves the factory. The second layer is that of predictive diagnostics, or extra information from the instruments to the operators and technicians. Micromotion Coriolis meters and Rosemount magnetic flow meters are both available with smart meter verification. This tool can be run in the background at configured intervals and are designed to check the health of the meter. This diagnostic tool can provide warnings of potential issues before the failure. For example, the smart meter verification on the Rosemount magnetic flow meter checks for all the critical components, including electrode circuit, coil circuit, and the electronics performance. A loss of measurement in the middle of a batch can not only create safety concerns, but it can also impact the ability to adequately complete the processing on specification. But Flow isn't the only business with such diagnostics. Fisher has great diagnostics through their FieldView digital valve controllers, or DVCs. And once the FieldView device has been correctly commissioned with all of the required data, it allows you to see all aspects of the valve's dynamic performance and mechanical integrity. So great, you've installed the safest instruments with predictive diagnostics, but those instruments can create a lot of information. So how do you manage it? The top layer would be the asset management system. So Asset Manager, specifically the Device Manager package of the Emerson AMS suite, allows you to quickly check the health of any connected device by viewing its status. And we have a graphic that shows the status colorations. They're easy to read. You can also change, store, compare, and transfer device configurations. You can define test schemes, schedule calibrations, and manage calibration data. You can easily filter alerts based on severity, location, or tag to quickly determine maintenance activities. And you can enable automatic generation of a historical record for each device maintenance activities, or essentially an audit trail. And as with all Emerson products, AMS Device Manager has been designed based on human-centered design principles, ensuring intuitive graphics and easy navigation for all level of users. In this webinar, I wanted to show you, one, how we've helped people in the industry to increase the amount of batches they can produce within a given time frame and using the existing assets. Two, how we have helped improve batch quality and consistency, allowing the sale of more on-spec product directly impacting the bottom line margin. And three, how Emerson's many safety solutions will improve your HSSE performance and ease compliance burden in an ever more stringent regulatory environment. In customer engagements, we saw improved batch cycle times of up to 30%, improved right first-time metrics of up to 21%, and an overall improvement in the HSSE performance. So in closing, automating your batch process is only part of the battle, and having confidence in your most critical measurements allows you to improve asset utilization. These precise measurements can give you more on-spec first-time batches, resulting in higher throughput and less downtime. And you'll be able to reduce waste, both in time and materials, by staying on spec with in situ measurements. Using multivariable components for calculated variables can offer additional process insights that will help improve your operational flexibility. And using safer instrument designs, predictive diagnostics, and actionable alerts can help lower unexpected maintenance events that could impact process and people safety. Thanks for attending this webinar, and now we have some time for questions.
Thank you so much, Robin, for all this great information. As Robin just mentioned, we're now going to open up for questions, so feel free to start asking your questions using that Q&A chat panel. We also have joining us for this question part of the webinar, Tanya Wyatt, the Chemical Marketing Manager for Micromotion. Welcome, Tanya.
Thank you.
And it looks like we've already got some questions in there, Robin, so I'll let you get started.
Okay, let's see. First one looks like for the batching application, is it possible to use 1 meter for multiple ingredients instead of the setup you showed with 1 meter? Yes, as long as the meter is properly sized for all of the ingredients, a single meter can be used for multiple ingredients, and it's relatively common to see that done. So we would just want to make sure that any of the ingredients that you would like to charge through a single meter, that we would run the sizing and make sure that the meter is properly sized to make sure that the accuracy of that meter will hold true with all of those ingredients. Okay. Does Emerson offer any training programs to keep my technicians and operators up to date? Yes. Emerson offers a lot of different educational opportunities. It is common for our sales folks to do on-site demonstrations for new products when they're released, but there are also some catalogs and some training catalogs for hands-on classes that we can offer. And those classes can be offered either at a factory environment or on your own site if you have a larger number of people that you would like to train at once. We can make those arrangements. I know additionally we have some of the Emerson businesses, such as Micromission, offer virtual classroom training programs that can be done online. So your salesperson should be able to help provide you with a list of options, and or you can, I think there's a tab of Contact Me. Is that correct, Allison?
Yes, there is at the very bottom of the screen. Yep.
Okay. So hopefully that will help you. But tons of opportunities for training are available.
I'll go ahead and jump in here. It looks like somebody's asking, does Emerson offer flow totalizers or integrator functions in the transmitters? And yes, we do have multiple totalizers, especially on some of the newer transmitters like the Model 5700 that Robin was mentioning. We do have the option to set up more than one totalizer so that you can do like a forward totalizer or reverse totalizer, but all of our transmitters do have a general totalizer function.
And I think since they're bidirectional, that we have that opportunity to do backwards and forwards totalizing, right?
Right, on some of the transmitters we can do that for sure.
Yep. Okay, let's see. Can I retrofit old meters with the new transmitters? So if you're referring to the 5700, you can retrofit it to remote 4-wire and 9-wire Elite F and H series sensors. If you'd like to get the smart meter verification, you'll need to have a 4-wire with the enhanced core already. So there are some retrofit opportunities there with the 5700. Let's see.
Looks like somebody is asking about if you have materials with different densities, how does the transmitter handle that? And so I guess from the Coriolis perspective, we are measuring both the flow and the density. So as it is outputting like a volumetric flow rate, the mass flow will not be impacted at all by the density of the fluid. So that is a direct measurement. But we're also measuring the density, so as the density changes, our volume flow rate will take that into account, and so you don't have to do any kind of adjustment. It's automatically handled. For like our fork densitometers, we are, again, measuring the density of the different materials, so we really don't have an issue with changing density of fluids.
Thanks, Tanya. I have another one on catalyst concentrations. Our catalyst concentration varies. Is that something we can measure? So it is possible and is done quite often with Coriolis meters and density forks, depending on the application, but you should check with your salesperson on a specific application because there are many factors to consider when trying to measure a catalyst concentration. So there's the line temperature accuracy, and it's also important to understand how much the density will change with the concentrations and the temperatures to make sure that the resolution of the device will be able to measure those changes. So it's application specific. It's done pretty often, but we would just want to make sure for any specific applications that we provide you with the best instrument to be able to do that before you decide. So really good question. We run into that quite often. Okay. Then we have a question on AMS here. Is the AMS device manager a separate system from the DCS? So the AMS device manager is available as a standalone version, and it can be as small as a 25 tag system, or you could, I think it's 25 tags, then 100 tags, and then anything multiple of 100. So it is sizable for a standalone version, but it is also available if you have a Delta V or an Ovation control system. It is available as a package on the DCS itself. So again, if you want more information on that, we can just let us know through the Contact Me form, and we can make sure that we get you the right information on that. And let's see. I think we only have a couple more.
Looks like there's only a couple more questions.
Yeah.
I can talk a little bit about, somebody asked, how does that real-time indication of multi-phase events work? And as Robin mentioned during the presentation, we have kind of the standard setup in the Model 5700 that basically just tells you that there's no entrained gas, there's some moderate entrained gas, and then there's severe entrained gas. So that's kind of an automatic diagnostic that's already in the Model 5700, but we do have other options in the Model 5700 and then in some of our other transmitters as well, like transient bubble and transient mist remediation. Those are really ideal if you have either a liquid with just some intermittent bubbles in it, or if you have a gas with just some intermittent liquid in it. Those basically allow you to look at what your density was prior to the event of the bubbles or the mist, and it basically goes back in time and kind of corrects for that flow that's going through there. We also have advanced phase measurement, which is something that is even more advanced, can be used for measuring mass and volume flow when you have two-phase applications. Has a lot of advanced algorithms in it, and if you want more details on any of this stuff around multi-phase, it's a pretty complicated subject, but we've done it a lot, so we would definitely like to talk to you in more detail. So again, you can use that Contact Me form on your dashboard, and we can get more information to you about that.
Perfect. Well, I think we're going to wrap it up here. Thank you so much, Robin, for this wonderful presentation, and Tanya for your assistance with these questions. As we've mentioned, if you think of any other questions after the webinar, don't hesitate to reach out to us using the Contact Us button at the bottom of the page there. Or I think on the last slide here, Robin, if we move to it, I think you've got your contact information there. And you can also directly contact Robin if you have any questions. So again, thank you for joining us today and for all these great questions. We will be sending out a recording of the webinar tomorrow along with the additional resources, so look out for that email. On behalf of our guests, Robin Sheree, as well as Tanya Wyatt, as well as everyone here at Emerson, we thank you again for joining us and taking the time to view the presentation, and we hope you have a great day. Thank you.